This is for Year 12 Specialists. It's the Kinematics Forces 2021 topic test question number 1. Okay, so we have a winch. The winch is pulling up the boat. So here is the winch pulling up the boat up the surface. The boat's 1,000 kilograms. It's inclined to 15 degrees. The winch applies a force of P on a rope. Okay, so and there's friction. Okay, so the boat's going up the ramp. So I need to add all of the forces. This will be force P. This will be a weight force, which will be 1,000 G. We'll have a normal reactive force, perpendicular to the surface, normal, and we will have a frictional force, which will be mu times the normal reactive force. So they're the 4 forces. And we have acceleration going up at 1/10. Okay, so find P. What I'd like to do is I'd like to break my weight force into 2 forces. One which is 1,000 G cos of 15 degrees. And the other one which is 1,000 G sine of 15 degrees. And I would like to consider forces in the I and forces in the J. And in the J, there is no acceleration whatsoever. So N equals 1,000 G cos of 15 degrees, which means in the I, my forces will be any resultant force in the direction of motion will equal any forces in the direction of motion, which is P, minus any forces in the opposite direction of motion, which is 1,000 G sine of 15, and also mu, which is 0.25, 0.25 times N. I'm going to replace R with MA, which is 1,000 times 1/10 equals P minus 1,000 G sine of 15 minus 1/4 times N, which is 1,000 G cos of 15 degrees, which means that P is going to equal 1,000 times 1/10 is 100 plus 1,000 G sine of 15 plus 1/4 1,000 G cos of 15. And putting all that on a calculator, I get 5,002.94. And I've been asked to do the nearest Newton, therefore P equals 5,003. So that's part A and part B. Looking at part C, when the boat reaches the top of the ramp, the rope breaks. If the rope breaks, P doesn't exist anymore because the rope has broken and the boat slides back down the ramp into the water. Find the acceleration of the boat as it slides down the ramp. Okay, so we now have the situation where we have our particle, we have a weight force, we have the normal reactive force, and now my friction is going in this direction because the object is now moving down in that direction, and we're asked to find acceleration. So I've got to break this into my 2 forces again, so that's 1,000 G, that's 15, that's 1,000 G sine of 15, 1,000 G cos of 15, so therefore N still equals 1,000 G cos of 15, but our resultant force in the direction of motion, which is going down in this case, is going to equal anything in the direction of motion, 1,000 G sine of 15, minus anything in the opposite direction of motion, which is 0.25 times n, which is 1000 g cos of 15. And that my 1000 times a equals all of that, which divide by 1000, put that on the calculator, I end up with 0.1699 meters per second squared, and I need to round that to 2 decimal places. Therefore, a equals 0.17 meters per second squared. So that's part C. Looking at part D. Okay, so the ramp is 6 meters long. Find the speed of the boat when it enters the water. I know that when the boat is at the top and P is cut, then I know that the boat is stationary. So U equals 0. I know that A equals 0.17. I know that the distance that it's travelling is 6 meters. Therefore, V squared equals U squared plus 2AS. V squared equals 0 plus 2 times 0.17 times 6. Therefore, V equals. Always use the most number of decimal places in the next calculation. So I've used this answer, and I've got 1.4279, and I'm rounding it to 2 decimal places. Therefore, V equals 1.43 meters per second. And in part E, how many seconds after the rope breaks will the boat be back in the water? I'm still under acceleration of, what was it? 0.1, what's my acceleration? 0.17. So here it is, 6 meters away, and U equals 0, A equals 0.17. How many seconds after will it be back in the water? Well, S equals UT plus a half AT squared. 6 equals 0 plus a half times 0.17 times T squared. So I'll put that on the calculator. I've used the longer version of acceleration, not the 0.17. Solve for X and I get 8.4039 seconds, which rounded to 1 decimal place gives you an answer of time is 8.4 seconds when the boat will reach the water.